Okay, I am so sorry about that. It seemed like the video just cut right off, so it kind of left us hanging here. But we were looking at this problem, and we were looking at the amount of data that is collected here. So we have 9 in our first bin, 3 in our next 2 bins, then 4, and then 1, and then 1. And so when we added all of those up, we know we have 21 nights that were tracked in total. So if we have 21 nights, the middle night for the median is going to be the 11th data point. Or not necessarily the 11th night, but the 11th data point from smallest to biggest is going to be in the middle. So here's 9, which means our 11th data point is going to be in this 5 to 10 bin. So we're going to select that, and then we can say that we know our median will be the 11th data point in the middle when the data is ordered smallest to biggest, and that will fall in our second bin between 5 to 10 minutes. Beautiful. Okay. Beautiful. Once you have that all plugged in, we can go ahead to the next slide. This has 2 different challenges. You're going to remove one of the values to change the mean, but not the median. And then on the right, you're going to remove a value to change the median, but not the mean. So you click a dot by removing it, and then you can hit start over to fix it. And you're going to play around with those 2 to change the mean and change the median. So right now, just to see where we're at, for the green one, if we add all of those up, let's see, we get 60, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 data points. So right now, our mean over here is 4, and our median, we can cross them out, get ourselves to the middle, is 3. And on the right, we have, is it the same? Oh, it's the set. It's the same data. Okay. So on the right, it's the same thing. Our mean is 4, and our median is 3. So you're going to play with those 2 options. The first one on the left, you want to change the mean, not the median. And then on the right, you want to change the median and not the mean. So try your best working through those 2 options. And then when you're all set, push ahead to the next slide. This is a spiral review. Select all the expressions that are equivalent to 2 times x plus 3. So we have 2 times x plus 3. So whenever we see a number outside of parentheses like this, we need to remember this is multiplication. So we can distribute this by doing 2 times x plus 2 times 3. And we see that right here. That is what we get when we distribute. And then when we simplify, 2 times x is just 2x. 2 times 3 is 6. So we have 2x plus 6. From the beginning, we could have also flipped what's being multiplied and done x plus 3 times 2. That is also going to be equivalent. Multiplication is commutative, so we can flip, right? 2 times 4 is the same as 4 times 2. The order doesn't matter when we're just multiplying. Beautiful. And the next slide, slide 10, we're looking at scientific notation. So the first, it says to evaluate your expression and write your solution in scientific notation. So we have 2 times 10 to the 4th, and we're multiplying that by 6 times 10 to the 5th. So first I would think about, well, what's 2 times 6? That gets us 12. Times 10. If we have 10 to the 4th, that is 10 fours that are all being multiplied. And we're multiplying that by 10 to the 5th, which is 5 tens. So all together, we have 9 tens that are being multiplied. So that's a 10 to the 9th. Now, this isn't in scientific notation yet. We need to add one more 0 because we don't want 2 digits in front with scientific notation. We want it to just have 1 digit and then a decimal. So this will be 1.2 times 10 to the 10th power. And this is scientific notation. It may have been a while since you've seen something like this, but it's just a way to write a really, really big number, right? 1.2 times 10 to the 10th power means that we're taking 1.2 and moving the decimal place 10 times. 5, 6, 7, 8, 9, 10. And all of these become zeros. So this really big number is this. $12 billion. That's a way to write 12 billion a little simpler. It's just 1.2 times 10 to the 10th. That's scientific notation. Let's try the second one. We have 3 divided by, or 3 times 10 to the negative 8th divided by 2 times 10 to the negative 3rd. Well, 3 divided by 2 is 1.5. And that looks good. That's in our scientific notation because it's just a number, point, decimal. We love that. We only want one number in front of the decimal when we're trying to get into scientific notation. And then we're going to multiply this by 10, and we got to figure out our exponent. So when we have something like x cubed, or let me do a bigger one, x to the 5th divided by x squared, right? What this means is we have 5 x's on top and 2 on the bottom. And the trick is some of them are going to cancel. So we would just end up here with 3 x's on top. This would be an x cubed. So a quick way to get that is to just take the exponents and subtract them. So over here we have -8 minus -3, which is going to be -8 plus 3, which gets us -5. So this is 1.5 times 10 to the -5. So I know you do some scientific notation in science class as well, but hopefully this feels okay so far. And make sure you're filling this out, plugging that in correctly. And when you're all set, go ahead to slide 11 and do the reflection, and make sure that you're saying something that you're proud of, as we talked about measures of center, looking at mean and median, how you're feeling about this topic and what you're feeling proud of. And then when you're all set, submit it into Schoology. If you have any questions, if you need any support or extra help from me, please reach out and let me know. I got you, and I'll talk to you in the next video. Bye, everyone.